Hello, today we're going to go through how to classify matter, and technically this is Learning Target 1.2. Now, as we go through this, some of this should sound somewhat familiar because we've done some very basic activities with elements and compounds, and there are probably some things that you're going to be hearing that came from the Classifying Matter online lesson. Now, as you go through the lesson, please make sure that you record all the notes that are posted for you for each of the boxes that are provided. Basically, if you take a look at our chart, we start right here. All matter is made up of mass and takes up space. So technically in chemistry, there's two categories of matter, pure matter versus unpure matter. I'm actually going to have us start with pure matter because you've had an opportunity to kind of get a basic understanding of what we call elements and compounds. So what makes matter pure is the fact that it cannot be physically separated, such as filtering or heating. So in chemistry, we call pure matter technically substances. So consider there's two categories of pure matter. We have what we call elements and compounds. So for example, water is an example of a compound, and we cannot physically separate water if we were to heat it, for example. If I boil water, the water is still water, H2O, whether it's a liquid in my pan or whether it's a gas that's given off as the water turns into a vapor. So pure substances cannot be physically separated by filtering or heating or by any physical means. Now let's look at the word element. Elements are the simplest substances in nature. They're listed on the periodic table. So what makes an element is the fact that it's made up of only one single kind of atom. So on the periodic table, there are approximately 120 simple substances. And basically, if we were to get the smallest piece of any element, we would call that an atom. Now consider that visualizing element and compound activity that we did at the beginning of the unit. If I were to visualize what an element looks like, I would probably see something like this. If you recall, we used the paper atoms. Please on your sheet record hydrogen atom, and hydrogen, for example, had a flap on it. So some of the elements had flaps and some of the elements had openings. And we're going to learn later in chemistry that those flaps and openings are actually going to represent the bonds that elements can make with each other as they come together to make more complex substances. So elements are considered pure, but compounds technically are also considered pure. So what makes a compound is that it's made up of two or more kinds of bonded atoms. So a good example that we've been referring to in class is water. So water is basically three atoms, two hydrogen atoms chemically bonded to an oxygen atom. So on your sheet, please record water as a good example. And if I were to get the smallest piece of water, keep in mind we talked about that word molecule. Molecules are groups of bonded atoms that come together to make a compound. So if I were to express the smallest piece of water I could get, I would call that piece of water a molecule. And one single molecule has three total atoms bonded together. Now, again, both elements and compounds are considered pure substances, and what makes them pure is the fact that they cannot be physically separated into smaller and broken down any further. Now, if you take a look at your classification chart, that considers the pure matter. On the bottom of the chart, we also have what we call unpure matter. So unpure matter technically are called mixtures. And what makes a mixture is the fact that you can physically separate the parts. You could filter it, you could heat it, and you could break down the substances into simpler substances. So a good example would be salt water. If I boil salt water, the water evaporates, the water's still H2O, but the salt's left behind. So it's an example of an unpure mixture. That salt and that water are not chemically locked together because of the fact that I cannot physically, or that I can, physically separate the two. Now from this, we can further subdivide mixtures. We have what are called homogeneous and heterogeneous. Now the word geneous simply refers to mixtures. So if you take a look at the prefix HOMO or HETERO, homo and hetero actually have some specific meanings. Homogeneous, the prefix HOMO means the same or alike. So basically a homogeneous mixture is an evenly mixed mixture. If I were to take a sample, all parts of it would pretty much be identical. They would be evenly mixed, and the stuff stays evenly mixed. Now, in comparison, an unevenly mixed mixture is what we call heterogeneous. Hetero means different, so it's an unevenly mixed mixture where the parts would separate, or there's a big difference in the size of the particles, and the substances are not evenly mixed together with each other. So let's further break down. This is where things get a little more complex. So let's consider, for example, a homogeneous mixture. If it is a liquid, we can call that evenly mixed mixture a solution. So a solution is a clear, homogeneous mixture, and it's made up of a solute, which is a solid, which is then dissolved in a solvent, a liquid. So in your online lesson that you read about, they gave the example of coffee as a solution. It has coffee beans that are mixed with water, and that creates a clear liquid mixture. So some people don't like coffee as an example because they're like, it doesn't look clear. But technically, there's a difference between dark versus clear. If light can pass through it, then it's considered a solution. If light can't pass through it to the other side, then that would be considered unclear. Another example I'd like you to record on your sheet of a solution would just be salt water. Salt dissolves into water, so salt is the solute and water is the solvent. Together they create an evenly mixed mixture where it's considered unpure because of the fact that, again, that salt and that water are not chemically locked together. They could be physically separated, for example, if I boiled the salt water. Now, lastly, let's go to heterogeneous. There's different categories of heterogeneous. So, for example, if I have a liquid or a gas, I can have either a colloid or a suspension. So colloids, this is probably one of the trickiest words on here. Colloids are an unclear mixture. They may look evenly mixed, but they're technically considered uneven because of the fact there's a big difference between the largest and smallest particles that are mixed together. So one of the distinguishing features of colloids is that they block light. They're not clear. So the examples that the online lesson provided were, for example, mayonnaise. Now, if you look at mayonnaise, it kind of looks like it's evenly mixed together, but technically it's considered unevenly mixed because of the fact that the fat that's in mayonnaise is hugely different from the size of all the other ingredients that are in the mayonnaise, all the different substances that are in it. So there's a big difference between the biggest and the smallest particles. Now, another good example is fog. Fog is a mixture of different particles in the air and water vapor. And again, fog is not clear. For example, light, if you drive in the fog, for example, you don't want to have your high beams on because all you see is light. The light's reflected back at you. The light does not pass through that mixture. Now, last but not least, there's one more category of an unevenly mixed mixture, which we call a suspension. So suspensions are liquid mixtures, and what makes a suspension is the fact that the particles that are mixed together, they settle into layers because of density differences. So when you mix them together, they may stay mixed together for a short time, but then they'll quickly settle into layers. So an example would be your blood. When you get a blood test, for example, they take your liquid mixture. There's many things in your blood. There's red blood cells, there's white blood cells, and what they do is they put it in a thing called a centrifuge and they spin it. And as they spin your liquid mixture, the different parts of your blood settle by density. The densest stuff sinks to the bottom, and then the less dense floats to the top. So they can basically mathematically figure out how many red blood cells you have, how many white blood cells you have, and from then they can infer, for example, that you have an infection because you have too many more white blood cells than a typically healthy person might have. So suspensions, again, are unique. They're fairly easily to recognize because of the fact that when the substances mix together, they don't stay mixed together. They do settle into layers based on densest substances sinking first. Now, if you take a look, please take a moment, make sure you record everything on my sheet, on your sheet. On the back side of this sheet, you'll find some practice vocabulary and examples to classify. Before you do that, though, you're going to be rotating through 24 lab stations that will allow you to look at everyday matter with a different eye. And your goal is to recognize basically our four main categories: pure substances, elements versus compounds, versus unpure matter, mixtures, homogeneous versus heterogeneous.